Hello, my name is Juan Pedro, and I'm presenting a way of, I'm describing division and looking at it as a new way. So, first off, I'm giving a brief definition for me, what is division. So, division is a natural way of relating two numbers with the condition that none of these numbers are equal to zero. They can't be zero. So this technique has been used by man since prehistoric ages as a tool to relate and solve problems in daily life and nature in general. So as an example, I'm studying in history. I'm studying Egypt right now. So I decided to do an example on Egypt. So in ancient Egypt, this method, division, was used to distribute equally the farming lands in the riverbed of the Nile, which is the main river in that area. So the limits were traced by an overseer. So the riverbed was split into equal parts, and each year the overseer would have to do the same process due to a flood, an annual flood that would erase all limits. And well, this was bad because it erased all the limits, but it was also good because it brought fertility and richness to the soil, and it allowed Egypt to prosper and have a stable income of food. What they did, as I said, was distribute the total land, the total riverbed, between the amount of farmers that paid tribute to the ruling class. In this case, is a pharaoh, which was kind of like the king back then. So, for example, I have an example right here. Let's imagine the overseer has in his domain 10,000 hectares, and there's 1,000 farmers that will receive an equal amount of land. So this is pretty basic. So you just divide 10 divided by 1 equals 10. So let's do it again. 10,000 divided by 1,000, 10. So then in this second example, let's assume that there is a population increase due to time. They get bigger naturally, so the town grows and it needs a larger amount of food, so the amount of farmers duplicates. So now it's 2,000 farmers and the same amount of land. And well, you just divide 10,000 hectares between or divided by 2,000 farmers equals to 5 hectares per farmer. So again, let's assume none of these facts are real. I'm just imagining all of this. So let's assume in this third case that there was a disease that reduced the population, and now you have the same land, which is 10,000 hectares, but now you have a smaller amount of farmers. You have 500 farmers. So again, what you do, 10,000 divided by 500 equals to 20 hectares per farmer. So, well, in this case, the constant is the dividend, which is the hectares, the land, and the divisor changes. So the divisor is the farmers. You're dividing the land by the farmers. So it changes, it fluctuates. And then you see 1,000 and 2,000 and 500 in the third case. So then I have the opposite of this. So in this case it's the opposite. So you have a constant in the divisor. So the farmers are always the same, but the dividend changes. So now the amount of land is changing. So in this first case, you have 10,000 hectares divided by 1,000 farmers equals to 10 hectares per farmer. In this second one, you have 20,000 hectares and you have the same amount of farmers, which is 1,000. And 20,000 divided by 1,000 equals to 20 hectares per farmer. That is the result. And finally, this third case, which is 30,000 hectares divided by 1,000 farmers, which is again the same. It never changes. This is very important. It never changes. This changes, this doesn't. The farmers are always the same. Hectares are changing. So 30,000 hectares divided by 1,000 farmers is equal to 30 hectares per farmer. And that will be all.